Hello everybody and welcome. In this video we're going to be going over 3 examples of factoring by grouping. So without further ado, let's get it. Example number 1. So we have this polynomial here and we want to factor this. And typically when you have 4 different terms, you're probably going to have to, factor by grouping. So the first thing we want to check to see is if any of these numbers have a common factor. So 5, 34, and -24, we want to check if those have a factor. In this case, they don't. So what we do here is we pretty much group them together, which is the name of the factor method that we're using. So what I'm going to do is I'm going to pretend this right here is one group, and then I'm going to pretend that these two terms over there are a group as well. So we're going to look at the first group, which is in blue, and we want to see what we can factor out of that. So 5x cubed minus 30x, I can factor out a 5, and I can factor out x squared, since 5 goes into both of those numbers, and there is at least an x squared in each of those variables. So if I factor that out, what I get remaining is x minus 6, just like that. All right. So now what we want to do is factor out the left side. So in green, we have 4x minus 24. So I can pull out a 4 from both of those numbers. And what I'll have left is x minus 6. Okay. So now when we're looking at this, we can see that the both terms here have an x minus 6. So that means I can go ahead and factor that out of this new equation that we found right here. So when we do that, what we have is x minus 6, because we factored that out. And then what we have left is just those two numbers. So we got 5x squared plus 4. All right, so this right here is our answer, and this example is complete. Example number 2. So we have this polynomial here, and we're going to factor this by grouping. So the first thing we want to do is check if I can pull out any number from these numbers here first. In this case, I can't. There's no factors that go into each one of those numbers. So what we're going to do is go ahead and start making our groups. So I'm going to go ahead and put these first two numbers as its own group, and then the second two as its own group as well. So looking at the blue group here, 8x squared plus 32x, I can pull out an 8x from both of those numbers. And what I have left would be x plus 4. And now we're going to look at the second group here in green. And one thing to note is whenever this number here is negative, usually you want to pull out a negative number. Okay? So whenever that's the case, most of the time, you're going to pull out a negative. So what we're going to get here is negative 7x minus 28. I can pull out a negative 7 from both of those. So I'm going to go ahead and put negative 7. And what I have left would be x plus 4. Okay, so now we're going to go ahead and factor out x plus 4 from both of those because we have that in common. So when we do that, what we get is x plus 4. And then we just write down what we have left. So we have 8x minus 7. All right, so this right here has been factored. That means this example is complete. Example number 3. So we have this polynomial here, and we're going to go ahead and do this the same way as the other ones. So first things first, we want to check if we can factor out any number out of the 4 variables that we have. In this case, we cannot. So what we do now is we just make our groups. I'm going to go ahead and put these two as a group, and then the second two as a group. All right, so looking at the blue one here, 10x cubed plus 50x squared, I can pull out a 10 and an x squared. And what we'll have left is x plus 5. Okay, and then when we're looking at the second group here, what we could always do is pull out a 1 from any, I guess, two sets of numbers. So what we get when we do that is, let me erase that here, we'll get plus 1 times, and then it's just going to be x plus 5 in there. All right, so now what we do is we factor out x plus 5 from both of those terms there. And what we end up getting is x plus 5 times whatever is left over, which is 10x squared plus 1. All right, so this problem has been factored, therefore this example is complete.